automatic, Addison.
In this tutorial, we will explore Lambda expressions and file input-output using C++. So let's begin by exploring Lambda expressions and how they can be used in robotics projects. Lambda expressions allow us to define anonymous functions inline, which is particularly useful for operations like sorting sensor data or defining quick callback functions. So let's create a new file over here, and we'll call it lambda _sensors.cpp. And let's type the following into the code editor. #include iostream, #include vector, #include algorithm. Okay, we're going to include this piece for stood sort, which we're going to use later. And let's do our main method, int main. So let's do stood vector int sensor readings equals 90, 85, 60, 75. And what other numbers should we put here? Let's just end it out with 100 for good measure. Don't forget to put our semicolon at the end there. And so this right here is just an example list of sensor readings, and could be temperature, temperature in Fahrenheit, some other sensor reading. And now let's do stood cout original readings. And so we do for int reading sensor readings. Okay, and let's do stood cout reading and close. Stood cout stood indel. So now let's use a lambda expression to sort the readings, and we're going to sort the readings in descending order. So I'm going to do down here, let's do stood sort sensor readings dot begin, comma sensor readings dot end. Okay, and let's do our bracket at the end here. And do int A, int B. Okay. Everything's looking good so far. Let's do our curly braces. And on the next line, we're going to do return A is greater than B. Okay, and this is just comparison criterion defined in line. And we're going to close it out like this. And now go down to here, and let's print the sorted readings. For int reading sensor readings stood cout reading do stood, cout, stood, end L, return 0. How are we looking? How are we looking? How are we looking? Pretty good, pretty good. Let's go down and expand this out just a little bit. So in this code, we start with the vector of integers representing sensor readings. The lambda expression is used within the stood sort function. Here, the lambda, int A, int B, right there, defines an inline function that tells stood sort how to compare two elements, specifying that we want to sort in descending order without the need for a separate function. So let's run the code. And you can see here we've got our original readings and our sorted readings displayed. And this shows how lambda expressions facilitate custom sorting in a concise manner, everything in line. So lambda functions, they allow for immediate definition of small scope functions directly within the code where they are needed, rather than outside this function, this main function. Now let's explore how to use the for each loop in C++. The for each loop is part of the C++ standard library. It provides a clear, concise way to perform operations on every element in a range, such as an array or a container like a vector. This is particularly useful in robotics for tasks like processing sensor data, where you need to apply the same operation to a series of values. Let's demonstrate the use of the for each loop with an example where we'll process a list of distances recorded by a robot's sensors. So let's create a new file, and we're going to call it foreachloop.cpp. And let's type the following into the code editor. #include IOStream, #include vector, #include algorithm, int main, and let's do stood vector int distances equal curly braces, and let's add some distances in here. 3, 7, 9. Don't forget our semicolon. Been doing Python a lot today, so I keep forgetting that semicolon. And now let's print the original distances. Stood cout, original distances. Let's do for int distance distances. Stood cout distance stood cout stood end L. All right, and now let's use a lambda expression with stood for each to increment each distance by 1. Let's go down here. Stood for each, and let's do distances dot begin, distances dot end. Let's do a bracket here, and let's do int, because it's going to be an integer for the distances, ampersand, and then d. And now we need to increment each element by 1. And to do that, we do the d plus equal 1. Increment, let's write a little note here, or say increment each element by 1. Let's go down here and do a closing semicolon. And now we need to print the updated distances. So we're going to do a stood cout updated distances. for int distance, distances, and we'll do stood, cout, distance. Okay. I'm going to do stood, cout, stood, and L. Let's do return 0. It's looking good, looking good, looking good. What do we do here? So in this example, we begin with a vector, what's going on? For each distance, again, see what's going on in here. It's going to be distances. Now we're good. Okay, so what's going on in here? In this example, we begin with a vector of integers representing distances recorded by a robot. We use stood for each along with a lambda expression, okay, that increments each element in the vector by 1. The lambda, which you can see right here, this lambda function directly modifies each element. You can see adding 1. So this demonstrates an efficient way to process and update data in place. And when we run the code right here, right-click Run Code, you should get output that looks like this. You should see both the original and the updated distances displayed, showing the practical application of the for each loop in modifying elements directly. Now let's explore how to handle file input and output in C++ and its applications in robotics projects. File input and output are essential operations in many programs, including robotics applications. In C++, the fstream library provides classes for reading from and writing to files. The ifstream class is used for reading from files, with the ofstream class is used for writing files. So enough talk. Let's just get some practice. That's how we learn. Let's create a new file called file_io example.cpp. Okay, and let's go up to the top and let's do #include iostream, #include fstream, #include string, int main. And in here, let's do stood, string, file name, and let's do robot_data.txt. And let's do stood of stream output _file, file name. Do if output file dot is open. Okay, and let's do output file. And we're going to do sensor 1, 10.5, and output file, sensor 2, 20.7, in output file, sensor 3, 15.2, in, and output file dot close. So stood, cout, data written to a file, file name, stood, indel. Okay, that's looking good. We need to now do our else statement. So let's do else stood, cout, unable to open file for writing. Okay. And we need to do stood indel. Okay. Everything looks good. Next, we'll explain this in a second, by the way. So next, let's do stood if stream and do input file, file name, stood string line, if input file dot is open, while stood get line input file line, and let's do stood cout line stood indel. So input file dot close, else statement here, and let's do stood cout unable to open file for reading indel. Oh, stood indel. And let's return 0. So what are we doing in this code? So in this code, we first create a file named robotdata.txt using an ofstream object. Ofstream. We check if the file successfully opened using the isOpen function. If the file is open, we write some sensor data to the file using this operator right here, the stream operator, and then we close the file. And then next, we read the data from the same file using an ifstream object. We check if the file successfully opened for reading, and if the file is open, we read the file line by line using getLine, and we print each line to the console. And then after reading, we close the file. And we run the code now, and here we get data written to a file, robotdata.txt. You can see it in the left panel right here. And all is good. So this confirms that the data was written to the file, and then it displays the contents of the file. So in robotics projects, file input-output can be used for various purposes, such as saving sensor data, reading configuration files, or storing robot states for analysis or debugging. Thank you for watching, and I'll see you in the next tutorial. Keep building.